Hello students, welcome to Saurav Sir's classes. This video is Time, Speed and Distance Part 2. And in this video, we will learn about some other formulas which are important for solving the problems based on time, speed and distance. In the previous video, we learned 4 formulas. So this video we will start with the 5th formula. Here, suppose there are two persons A and B who are traveling from point P to Q. Let this be the point P and this be the point Q. They are traveling with the speed A and B respectively. Now B has reached Q first and then returned immediately and meet A at point R. So suppose this is point R. So the distance travelled by A is distance travelled by A or dA is equals to PR, and the distance travelled by B, that is dB, is PQ plus QR. So dA and dB are given by the formulas. dA is equals to 2 into D into A divided by A plus B, where D is the distance, that is PQ, and dB is equals to 2 into D into B divided by A plus B. So these are the formula of the distance travelled by A and B. In the next formula, suppose there is a man that walks with A by Bth of his usual speed. That is, for example, if the speed of a man is Sm, then he is walking with the speed of A by B Sm. He takes T more hours to cover a certain distance. Then what would be the time taken to cover the same distance with his usual speed? This time is given by the formula. So let us denote it by Tu. The time is equals to A divided by B minus A into T, this hour. So this is the formula for the time taken by the person to cover the same distance with his usual speed. Next we have, suppose a person goes to certain distance, say a person goes in a certain distance, say D, with a speed S1 km per hour and then returns back with the speed of S2 km per hour. The total time taken for the journey, if it is given by T, then the distance travelled by the person is given by, that is, our D is equals to T into S1 into S2 divided by S1 plus S2. Next, we will learn some important formulas to deal with the problems based on train. But before that, suppose there are two objects moving with the speed, two objects say A and B, moving with the speed A km per hour and B km per hour respectively, then the relative speed is equals to A plus B if the two objects, that is A and B, are moving in opposite direction, that is A and B are moving in opposite direction and their relative speed is equals to, now suppose B is greater than A, then their relative speed would be B minus A if A and B are moving in same directions. Now suppose there is a train A with its length is equals to length is say x meters. Then when a person, if that train passes a pole, a single pole or a man standing or any other object like a pole or a man or a tree, etc., then the distance travelled by the train is equal to its length, that is x meter. Now suppose a train passes a stationary object, say bridge, platform, or another train, whether it's stationary or moving, and suppose that particular bridge or train or platform, whatever it is, has the length of y meter, then the total distance travelled by the train is given by x plus y meters. So if we have two trains with length x and y that are moving in opposite direction with speed u and v respectively, then the time taken by the trains to cross each other is equal to x plus y divided by u plus v. Whereas if the two trains are moving in same direction with speed u and v such that u is greater than v, then the time taken by the faster train to cross the slower train is given by x plus y divided by u minus v. This is the time taken by the faster train to cross the slower train. Next we have that suppose we have two trains, say A and B, who have started from the stations P and Q and have started moving towards each other with speed A and B respectively. And when they meet each other, it is found that train A has covered d more distance than train B. Then the distance between the stations P and Q is given by, so here we have P and Q, stations P and Q. A has started, suppose train A has started from station P and B has started from station Q. They are moving towards each other. Suppose they meet at point R. So this distance, that is PR, is greater than this distance, that is RQ, by D. So here we have to find the total distance, that is PQ. Let us denote it as D. Then D is given by A plus B divided by A minus B into D. So this is the formula for the distance between the stations P and Q. Next, suppose we have two trains that leave station P for Q at time T1 and T2 and travel with the speed A and B respectively. Then the distance D. Now here we have the speed B is greater than A. Then the distance D from P, where the two trains will meet, is given by, that is D is equals to difference in time into the product of their speed divided by difference of speed or difference in speed. This is equals to T2 minus T1 into A into B divided by B minus A, where B is greater than A and T2 is greater than T1.